The purpose of my experiment, the electrical resistance of certain household items and metals, was to find the conductor with the least resistance and therefore the most efficient conductor. My hypothesis was that all of the metals would have the least resistance and therefore be the best conductors. The wetter household items would have the next least amount of resistance and be the second best group of conductors, and that the dry household items would have the most resistance and be the worst group of conductors. For my procedure, I gathered my materials that were to be tested. I put new batteries in the multimeter, the device that was to test the resistance of the items, and turned the multimeter on. I then put the multimeter's probes into the side of the items that I tested, and took the number that was shown as the resistance of that object. I recorded the number that was shown, and that number was the amount of resistance that item had. My graph that I made shows the resistance of the objects that I tested, substituting 300 for infinity, meaning that it didn't conduct any electricity. At the end of my experiment, my results stated that the copper wire was the best conductor with the least resistance at 0.4. Then came picture frame hanging wire and stranded copper speaker wire at 0.5. Then came coax cable at 0.6 and aluminum wire at 1. After that was the platinum watch at 1.187, the zinc-coated steel nail at 1.3, the Progresso soup can at 2.5, and the metal coat hanger at 3.005. Then came the ice cube at 6.04 and the wet paper towel at 7. The next best conductors were the glass of water at 26.48, an apple at 38.2, a strawberry at 39.65, a blueberry at 71.9, a cherry tomato at 151.3, and the wet pretzel at 218.2. Finally came the pretzel and paper towel with a resistance of infinity, meaning that they conducted no electricity. My hypothesis was right in the order of the most conductive to the least conductive.